let's prove that some of the examples, that the first two I will do, are indeed random sets. Okay, so let's remind ourselves. We have x, which is a random variable, and random variable, and x is just putting curly brackets around the x. Okay, it's all of omega for each omega is like that. Okay, so claim so that x is a random set. Okay, so let's prove it. Okay, we need just to look at a compact set. So let K be a compact set in RD. Okay. And we can, so K is a compact set, so it's a Borel set. So let's look at the X. Let's start with just X, the capital X. Okay, so X minus 1, the inverse of the set K, okay, is equal to all the omegas, such that X of omega intersection with K is non-empty, okay, which is equal to all the omegas. Okay, so X of omega is just this, okay, small x of omega intersection with K is non-empty. Okay, we use the definition, which means that, okay, the intersection is only happening when x, small x, the random variable, is an element of K. Okay, and by the definition of what a random variable is, and since K is a Borel set, okay, this is an element of the sigma algebra. So capital X here is indeed a random set. The second example involved y lower and y upper, such that the probability that this happens, okay, is equal to 1. Okay, and we defined X to be the interval between y lower and y upper, and those are random variables in R. So the claim is that X is a random set. Okay, let's write down the proof. Let K be compact set in R. Okay, X minus 1 of K is equal, by the definition, all the omegas, such that K, so X of omega intersection with K is non-empty. Okay, so that will mean why? How can that happen? Okay, so if we have the set K, X of omega is an interval. Okay, that can happen if either. Okay, so let's write down. It's all the omegas for which, okay, the y lower, okay, is less than the infimum of K, okay, and y upper, okay, is less than the supremum of K. Okay, so basically YL falls out of the set K, but Y upper is inside the set K, and I should say also, okay, like this. Okay, and then actually I don't need that. It's just Y upper is in between, and I can take also the omegas for which while lower is in between the infimum of K and the supremum of K. Okay, that will also work, or both of them. Okay, both of them can also be okay, while lower is bigger, sorry, I would say like this, that both of them are in between. Okay, so we have the infimum of K and the y lower and the y upper, both of them are inside. Anyway, all these sets, okay, because K, infimum of K and supremum of K is compact, those exist, okay? All these sets that I just wrote down here, each one of them is an element of the sigma algebra, okay? So it's a union, okay? This is in F, this is in F. All these sets will be in the sigma algebra, so their union is in the sigma algebra. All of that is in F, okay? So X is a random set, and that concludes the proof. Okay, so that's another example that we discussed. The third one, I leave it to you. It's going to follow more or less the same steps, and you can try it yourself. Okay, thank you.